Hi, Eric. It is a pleasure to have you here at the keynote interview for the Enterprise Rack Challenge. We wanted to have this kind of keynote for a long time, even before the Enterprise Rack Challenge was envisioned in its current iteration. And everybody was super excited to hear that you have a time and opportunity. So thank you very much.
For
I must
inviting
say
me.
that, well, I've been developing this platform for the Enterprise Rack Challenge, and currently we have almost 500 teams registered there, and they have run more than 100,000 AI agent simulations on that platform, which is like astonishing number for a couple of weeks. That the lessons that I've took over from your book and from your works on paying attention to the language, paying attention to the context, paying attention to how entities communicate, how the information flows, how the things are named, how precisely they are named. It was tremendous and very valuable, both in AI coding and in shaping the domain, which is others that we're doing. And so today, like we came here thanks to your work, thanks to the work that you've done in the past decades. And now it would be wonderful to hear, like, what do you think about how, from your own perspective, from your own unique perspective, like, it looks like DDD and AI, they allow so many things, they answer, allow to answer so many questions. But how does this look from your perspective?
Well, I am very excited about the AI and about LLMs in particular. And I think that first of all, as I've pointed out, the subtitle of the book is Tackling Complexity in the Heart of Software. It's not like let's make object-oriented programming or let's you know, it's tackling complexity in the domain. So when you think about what these things are, they are ways of representing the complexity in the domain. And in particular, it turns out they're, very language-oriented ways of doing it. I mean, they are literally language models. So I think it shouldn't be too surprising that it kind of you know, hit some of my particular, kind of got me pulled in. Uh, it fits both the problem that I've mostly focused on and even my orientation around language and about representation, like models. So yeah.
I heard from you that you are doing a very interesting experiment on the connection between the DDD software and linguistics, where you have been feeding code files into the models and asking to classify business domains based on the language that is present in the files using Nike's codes. So, like, could you tell a bit more about this experiment and what you were trying to achieve with that?
Sure. I mean, I've done quite a few experiments, and this particular one, though, is the most recent one I've talked about. And so the experiment is that I put the text of, say, a code file in, and I want it to tell me originally, well, I'll explain in a minute what I was originally going for, but I want it to tell me what domains are being addressed in this code. Originally, I envisioned, and I still might play around with this, an application that is a sort of application that I always used to want to have, which would be something that would let you look at an unfamiliar code base and find where it's actually addressing domain issues, and specifically like which domains. So if you look at a large system, it'll have a lot of technical stuff and it'll have maybe multiple different domains that it might be dealing with. So how do you find that stuff and how do you zero in on the parts that you really should be looking at? And there were a few other things I wanted to do, which I haven't fully gotten around to, like looking at how it addresses it, like that. what is the nature of the language in those parts, and maybe characterizing the bounded context. But I haven't gotten there yet, but I'm still doing it because what I found was that just the starting point wasn't so easy. Like just to get the an LLM to tell you what domains are uh, in a certain file, let's say. And because it always gives you a different answer, even if it's always a sort of a correct answer, it doesn't use the same words every time. It will describe either, I mean, you can, of course, so I don't want to try to explain the whole thing because I actually wrote a blog article about this, which is probably people who are actually interested in the details can read that.
We'll link that
But
in the comment notes.
the bottom line is, if you think about this, you're asking two different tasks in one. You're asking it, of course, to a classification task. Here is some text, classify this text according to which domains that it's in. But before it can do that task, it has to do a modeling task, an abstraction task. And I submit that LLMs are very good at classification, but they're not so good at modeling and abstraction. They can do it. In order to do it, you need elaborate prompting techniques to let them retry and refine their answer. If you want to, but it's even worse because if you give that sort of prompt and you say, what domains are these? If you do that on, say, each file within a project, then effectively you're asking it again and again to classify and invent a schema for that classification. So you end up with a whole bunch of different um, classification schemes, which is not what you want at all. So then you have to come up with a thing that will sort of sample across the project and then create a taxonomy and then classify according to that taxonomy, which actually works. But so what I eventually realized is people have created taxonomies of domains. There are a lot of them, but one of them is the NAICS, which is used by the Census Bureau of the United States to classify every business and nonprofit and so on in the country as they do the census. So it is, pretty complete. And also, it's been hammered on by a lot of people for a long time. And so I started using the top couple of levels of that classification, which fits one of the old patterns of DDD, which is the um, published language. It's saying, we will have a model which we will refine quite a bit, and essentially then that model can be used, not the code, not there's no code from that, right? Just the concepts themselves. In this case, a list of categories that you would put domains into. What I discovered was that it takes you from a situation where it's fairly difficult task for the LLM. You need a big LLM and you need an elaborate prompting method to a very simple task that can be handled by quite a small one and with a high accuracy level. In fact, oddly enough, you don't even have to put the categories in uh, because the LLMs in their pre-training have already encountered this particular scheme. Honestly, I don't know whether that makes it better or worse. I do put the classifications in because, the it makes it more of a RAG problem than I mean, I don't want the LLM generally to respond out of its general knowledge. That kind of brings us back around to something like the RAG challenge, right? Why would we want there are cases where you do, but generally speaking, you don't want the LLM to answer from its pre-training knowledge.
Because the
You want to
business is unique.
answer Yeah, you want it to have built up its understanding of how things fit together well enough to interpret data that you give it. So anyway, I've been going on about this one for quite a while, but so I'll try to. The point is, I didn't start out saying, "Oh, I want to classify things using NAICS codes." That was something that came along toward the end of my experiment. Uh, but it really worked. And then I realized, oh, this is actually one of those old DDD patterns. It's nice when that happens. Sometimes it doesn't, sometimes things really are different, but not that time, turned out.
So then, since we started talking about that, so you're saying that some things are resembling the old times in the pre-AI era, some things are new. So like when you look at the AI and the enterprises, so like what are the new problems or like radically new things that were impossible before and they're kind of blowing your mind now?
I mean, the biggest one really is the ability to deal with natural language. That is a thing that, you know, people have tried and tried and tried and come up with inadequate solutions to that until now. And it's truly new. And I've been interested in various kinds of analysis of natural text. We would do things like look at the significance of different words. You know, you can learn a lot about text by looking at the word usage and correlating that word usage with other text samples. And you can infer a tremendous amount, but you can never quite get to what is the meaning of this information or this textual information. And now we can do that. I mean, you can just say, well, here is a data schema. I want you to, and I want you to extract the information from this text and fill out this form, basically. And so, and all kinds of things. And sometimes it's not natural language. And the particular experiment I did, it was code, but code has the same problem in spite of being extremely structured. The aspects of it that I wanted to look at were essentially, not very structured, like what kind of words did people choose for the names of the functions and fields and so on. I mean, if you're trying to figure out what domain a thing is about, what do you look at? You don't look at the actual Python syntax part. You look at the part that's kind of left when you subtract that out. And I've tried a lot of different ways of tackling that sort of problem, and nothing really worked. And now it's almost a solved problem. And that, I think, so I would say, I don't think we know yet just what exactly the impact of that is. But when you get such a basic new capability, you can't, you have to expect that it's going to be a big thing.
So, in other words, you're saying like that the amazing part of the large language models, it's not like their reasoning capabilities, their thinking capabilities, but that they're actually like a glue between the human world, human language, and the automation in the structured language, if I get it right.
Yeah, I mean, in the examples that I've talked about so far, that's definitely true. And I think that we're kind of at a stage right now where most of the time when I'm trying to do something, I find myself steering away from the reasoning and toward these more structured kind of classification problems that a tremendous range of interesting domain problems can be framed as classification problems. In fact, I mean, even the pre-training of a language model is done by saying your task is to predict the next word. But the way they do that is they enumerate all the tokens and then they say the next word will be, and it has to classify among those tokens. So this the choice of classification it gives you a lot of possible possible interesting problems. But also, as I said, interpreting natural language, just saying what is there, what is in that email message, I mean, information, and then bridging from that into the structured software that we've used for, I don't know, 50 years or so, uh, but with increasing complexity over the years, increasing abilities to do abstractions. So what I'm not saying I don't think that the reasoning abilities will be important, but probably the low-hanging fruit isn't there in that part right now. And I could easily be proven wrong when we hear that some, really important and amazing thing was done using the reasoning. The closest I've seen personally to that part really working is the coding agents that I use a lot. And they do a certain level of reasoning, but I find that I have to stay right on top of them. I don't find their work to be sort of first rate. It's good enough that it isn't that I am happy to substitute a lot of my mundane work with that. And also their knowledge of every little framework, API, you know, all those things. There's where, by the way, the pre-training knowledge,
Yeah.
as opposed to RAG, I don't have to feed in a data file that says this is how the Python syntax works, and this is these are the commonly used libraries in Python. It already knows all of that, and then it does a certain level of reasoning, without which it couldn't do what it does, right? Then it does all kinds of dumb things. It it's weird. It's how uneven it is, right? So that at times it lures you in by seeming so smart, and then you find something. I mean, I'm sure that probably most of the people who are listening to this have similar experiences. The coding tools are amazing, and I would hate to have to work without them at this point. I'm completely dependent on
Which
Claude
coding
Code.
tools does Eric Evans use?
Well, of late, I've mostly used Claude Code, and I always like go peeking, having my little dalliances here and there. But Claude Code's drawn me in for a few reasons. I like the way they put everything together, but I think the thing that keeps me using it is in no small part just the principle that it is better for a human to learn one tool really well than to barely understand five different tools that are constantly changing. Even keeping up with all the new features that Anthropic puts into Claude Code is difficult for me. Because there's I don't know, sub-agents, which is exciting, and so on. I've actually, yeah, so I kind of immerse myself in one tool mostly, not because necessarily it's the very best. I mean, I think at the moment that I made that decision, it probably was because I spent quite a bit of effort looking, but these things are changing so fast, I really have no idea. But for me, what works better is to know one tool really well. And for that, I have to kind of stick to one. Uh, I just don't have the bandwidth to learn two of them in depth. But at some point, it's quite possible. I do listen to people who say, oh, I used to like Claude Code, but now this other one is so good. Um, I also have started using Claude Code for other things that aren't even software related. Like, uh, I had this idea that, so we had a lot of work on this house over the last few years. It's an old house and it needs a lot of attention from a lot of carpenters and plumbers and electricians and roofers and so on. So all of this is complex and not the thing that I really enjoy managing. Just keeping track of what's going on and who I need to follow up on and everything. So I I thought, yeah, it would be nice if there were software that helped me keep track of this. But then there is, of course, there's software for everything, but it's not very good. And so I had this idea that I tried a few different things, but what I eventually converged on is putting most of the information I had into some markdown files, organized in a way that I could fairly easily understand, consolidating therefore from, some contacts in my that I could only find by like going into my text messages and finding the old texts and uh, or looking at old invoices. But anyway, putting this in Markdowns and then creating a Claude Code project and then interacting with Claude Code and explaining to it what I was trying to do, which was to manage all this stuff. And I said, I want you to manage this stuff. And it made a Claude MD file that explained what the purpose of this project was. It wasn't a coding project, but if you think of it as like files that you're transforming, folders full of information that you're searching through and extracting, and so like I started dumping as I found old invoices, I would just dump them into folders in this project. And then I would tell it, oh, there's new invoices in this folder, and it would look at those PDF invoices and say, that's a contractor that we haven't got in our contractors.ind file.
Nice.
Add their information there. And I also have this other file where all the like expenses have kind of just been enumerated, so I can say, well, like what obscene amount of money have we spent on this? But actually, more practically, because there's a tax implication when we finally sell the house. Not interesting. That's my whole point. It isn't interesting to me, but it's something I have to do. So yeah, it has been really interesting because here I get to see a little of the adaptability of like when you interact with Cloud Code in its intended way, and you're telling it to write code and structure a coding project, how can you tell, is that general intelligence there? I mean, how general is the intelligence, right? And but when you have it organize your house maintenance and remodeling and whatever, it has to have some generalization to do that. I don't think Anthropic put any real investment into that. I mean, I could be wrong, but I really doubt if that was something they put any real attention to, right?
It just
So
happened.
it just happened. It comes, it emerges from whatever general abilities this has and the similarity of the tasks. I mean, I won't say that it just takes care of everything. I certainly have to coach it along quite a bit. And then, okay, but you were asking, about the project that my little side project with the classification, but another side project. So for a long time, I've done various side projects, and I mean long before AI, where I would try to analyze my email history because there's so much valuable data lost in my old emails and the Google search on, like I have Gmail and Google search on that is weirdly weak. I mean, I say weirdly weak because we know that Google, when it wants to, can be very good at search, right? And yet, the tool they give you to search your own emails, if you know an exact set of unusual words to search for, it seems not guaranteed. I don't understand why it's as bad as it is, but okay. So I thought, well, I'll write something. And so years ago, I did this and I used various time series statistics to find interesting things about, like, when did I talk to Renat? Not like the one time, one at a time, like everything was aggregated into statistics. So, like, when did Renat and I talk a lot? Um, and little bursts of activity, and say, oh, with you, it would go way back there. Like, I don't remember, but my tool would have. So, and you see, oh, there was this burst in 2016 or something, and then another burst in 2022, and another burst in 2025. And okay, but that wasn't AI, that was statistics
Hmm.
and good old-fashioned, data manipulation. Uh, and I created a domain model. I think one of my purposes at the time, although this is a thing, I don't always release these experiments, and I should put more energy into like getting these things out there because I do occasionally and but not usually. So I don't think I ever put it out there. But part of my purpose with this project was to say people are way too narrow about what they think about when they say domain model. They're
Hmm.
stuck almost with this kind of object-oriented
Hmm.
view, and even kind of a weak object-oriented view, so that if it isn't there in the structure of the objects and in the methods that manipulate that, then they don't think of it as a model. But in this case, I said, well, here's a model of the relationships that are um, my relationships with people. Here's a model of my relationships with people. And using the data in the metadata of emails, I can compute this, and I can say, when was I actively connected to Rina? Or who was I actively connected to that I'm not actively connected to now? Like, who have I kind of lost touch with? And questions like that can be answered with a statistical model. There's an entity there, but it doesn't have to be represented with an object. In fact, I didn't find object-oriented programming to be all that useful. I think I wrote that one in Clojure, which
Hmm.
is a Lisp dialect, so it was functional programming. But it was absolutely a domain model, and so anyway, I've digressed from AI because what
Hmm.
I was saying is I've done this email analysis thing again and again. But when I did the statistical one, I used to think I have to avoid anything about the actual content of the emails. I absolutely avoid that because it was a morass that I would get into, and I would spend months trying to figure out how you'd know if an email maybe was on a certain topic or whatever.
Hmm.
And so I avoided that altogether. But now I thought, I can come back around to this now. I could add a module, except the old thing was so I didn't want to go back to the old thing. So I just said, okay, I'll make a new thing that will focus on that. Like, uh, you know, what are these emails about? And I did get into that a little, but I was like, okay, it can tell you, it can summarize an email. It's good at that. That's boring. I thought, what is a real problem I have? And a real problem I have is the search. The search of email is so terrible. And so I thought maybe I could tackle that. And I started making a thing that is basically a RAG, uh, but using email search. So what it would do is you would say, okay, I want to find this electrician that I corresponded with years ago, and I have no idea what his name is. And if I search for electrician in Gmail, I get some hits, but it isn't the right one. Maybe we never actually used the word electrician in our conversation. And so I wrote a thing which would take a, you'd say what you're looking for. It would use an LLM to come up with some search terms. It would do the searches and then get a big chunk of email text and, use an LLM to try to see if it could find the thing you're looking for. Um, and this worked pretty well, as you could imagine. It is the sort of thing, in fact, that I'm confident that the people listening to this have done because it is called the RAG challenge. And then I said, well, this is great, but this app that I built is terrible. So I thought I was at the time intrigued by the MCPs, the whole idea that you would make tools for agents to use. And I thought, what if uh, I take this thing and I make it a tool because what I found was, so about this time, Claude desktop, not Claude Code, um, Claude desktop had introduced connectors to, so you could set it up so it could search your
Saying that you looked in the Claude desktop, not the Claude code, because it had the connectors.
right. That probably dates the time of this experiment pretty precisely. But it had the connectors. The thing is that I found that when it did, if you asked it a question like, I'm trying to remember an electrician that it would do a search for plausible terms, and uh, then it would look through the stuff. It did the right things, but it would choke. It would run out of messages before it got anywhere. So I realized that you needed a better tool. The connector wasn't the right level. The connector brought back entire messages for one thing. And so what it needed was something that could condense history. So I created a tool that was basically the part of my old one that did the actual search. So once it had search terms, there was a piece of software that was not AI that did a search, and it used this thing Gmail calls a snippet as a proxy for a kind of short version, and then I did some stuff that com so I did a lot of experiments, but what I discovered was that it would do a better job if you took the old conversations and you took just the snippet and then you took the person's name. So like Renat Abdullah colon and the snippet for what you said, Eric Evans colon and the snippet for what I said in chronological order and give it that as if it were a sort of a transcript of a conversation. Uh, um, and that two things happen then. One is it's tremendously condensed, right? So that you could have like a huge chunk of history of, in this case, I'm kind of switching examples back and forth, but say the conversation between Eric and Renat could have a huge chunk of the history in a relatively short document, without all the noise, right? No metadata, no detailed, and it was uncanny at interpreting this, even though some of the details of the messages, of course, were snipped out. All you had was these kind of brief summaries. But the context you got from getting the whole conversation instead of a single message, I think added more than that condensation lost. And the result was that this combination really worked well. So I worked more on, uh, I found sometimes, it would, like if you were doing the search for the electrician on my entire email history, it would come back with ridiculous numbers of messages because it would pick several keywords, contractor or electrician or wiring or, and it would come back with too much. So I made this other tool. I mean, it was one MCP, but it had a few tools that it provided. One was the preview, and all this one would do, give it some keywords, and it comes back with an estimate of how many messages it would hit and a little sample of what sort of stuff. So, and then I put in quite a bit of prompt to explain how to use it. So that what the tool would do when then the whole thing was working well, the tool would understand that what it was supposed to do is use the preview until it was getting a reasonable number of messages that were hitting the right kind of things, and then use the real tool to get back that sort of transcript-like thing, and then try to answer the question. And so that was like really gave me the feeling that this thing had some intelligence, but you really have to feed it the right information. And that is domain specific. Like, what are you can't really fully generalize, well, how do you extract information from an email? You have to think, well, is the kind of thing that I'm talking about in this case more conveyed by the back and forth, like getting more back and forth cleanly labeled with a person's name, not an identifier of some kind, so that the LLM, which has been trained on a lot of dialogue-like stuff, might tune into that concept of two people having a conversation, the aspect I want to focus on. It's sort of context engineering, I guess, if you're really deciding what that context should contain. And really focusing on which aspect of this data do you want to extract and then structure for the benefit of the LLM to make a task that it's good at. And then you have to have a sense of what are these things good at and what are they not so good at. And like I already knew that Claude Code, given the simple search tool that it had, simply just couldn't do the kind of, find all the electricians that I've ever dealt with by way of email. And then, list when I list them all and their contact information, because I'm going to have to reach out to them and try to find another electrician. Couldn't do it. Uh, it would start and it would be doing just the right sorts of things, and then it would just choke on the volume of emails. Then having entire email messages come back and searches that were too broad, so broad that it would have to, if it had unlimited resources, it could do it, I guess, but that's not how things work. But this other, with experimenting until you find that right set of information. And then, I mean, one part that was really exciting to me from thinking about how agents work was the idea that I needed to give it two tools. One that it could use to fine-tune its own search terms, to find a set of search terms that would not overwhelm it with huge volume and yet would be hitting the right kinds of things, right? And then the second tool, which it used to actually bring it back, but a big single chunk organized into that dialogue form, which was which it could recognize as a conversation. And
And
it worked nicely.
and I think like you're like to reflect on what you have been saying, you're hitting here like two very important problems which are being solved by the teams that are like pushing state of the art. The first one is like initially you're in the beginning of our conversation today, you were saying that like classification tasks are easy, like when you take some input and classify it to one of the predetermined parameters. But as you have been exploring it deeper, when you were talking about the emails, about finding information, this sounds like it's no longer a classification task, but it's actively manipulating information. It's like doing something with the information until it's like you discover something locked within. And as you have been explaining, it requires two very specific approaches. One, like they refer to as like reducing the context, reducing the amount of information, because we all know that there are three hallucination triggers, the three things that can make LLM make things up, and everybody's scared of LLMs hallucinating and lying. And this is caused if there is too much information in the input context, if there is too little important information in the context, or if the task is too complex.
Hmm.
And the other part is like coming up with the right tools, and not even just right tools that have the right shape, that don't overwhelm the model, but even have the right names. And we can even measure that. So probably like 3 days ago, I published a sample for the Enterprise Rack Challenge, like it's open source code that anybody can try to use to get a decent score. And it was scoring something like 50 out of the box. And then I've done a set of tiny changes. And these changes were not even meaningful. I just renamed a few tools
Hmm.
because it was using APIs by default, and I just renamed a few tools and changed the shape of information, mostly renaming. And that was enough to get 10% accuracy or more. And in one of the other projects, we were had to extract a ton of
Just
information.
ask you a question though about
Yeah.
your renaming.
Yes.
Were the new names, did you think, more expressive to a human? Like if a human were trying to understand what the tool was for, would a human have had an easier time? Or,
Absolutely.
yeah, because I find it kind of amazing still that that's actually a pretty good guide. You know, like if you're thinking about like how am I going to make the LLM respond better to this thing? Well, what would make a human find this thing clearer? You know, the same things we do with the ubiquitous language stuff. But anyway, so I want
Exactly.
to hear the next thing. I just wanted to clarify, like, what was it about that? Yeah, the renaming.
Yes, it's just renaming, it's just making clarifying. And the mental model that I usually have in my head is that what if I were to like to invite on this project a apprentice or an intern from the street that knows nothing about the business.
Yeah,
He's very talented. He has a lot of spare time on his hands, but he needs like clear and clear-cut explanations to have to be very concrete. And on the other project where we had to extract a lot of component specifications from the datasheets, which were complex, they had diagrams and tables. The most of the magic was done in a single schema-guided reasoning prompt, and the accuracy was gained by simply finding the right terms. Because the models of themselves, they're highly intelligent, they know everything about the internet, but they just need to be guided to the right context. And it feels like a magic if you find the right combination of words and if you utter them in the right sequence, then you get high accuracy and they get something that was impossible to do before for decades. And now it's possible even by a tiny team. Is
yeah.
that the feeling that you also have, or like is it different?
No, that is you know, and so as I was talking earlier, I kind of got lost in the details of those particular experiments. But I do like to go to concrete examples when possible. And so, but to, pull it back up to the broad view, I think, yeah, this thing you're talking about absolutely is my own experience. And it's very much the ubiquitous language. It's like we refine the way we talk about the problem until we can clearly, concisely, unambiguously state what the problem is and our approach to the solution and what the solution is. So these things fit within our very sharp, clear language. And it has always been the case in the past that you could say, these names of things in the software are just for the humans. It's for us. We need them, but the computer doesn't care what you call it. If you just called every variable A, B, C, D, E as you come to it, then it would behave in exactly the same way. But that's not really true with the LLMs. They really respond to code that has, well, not just code, but language that's carefully crafted. Uh, yeah. So the ubiquitous language turns out to be useful for AI. And along with ubiquitous language comes a bounded context because that kind of sharpness of language um, requires some kind of a boundary where we can say we're being really consistent and unambiguous, but only within this boundary. If I say something about uh, how emails are structured in a particular language, um, but I'm only saying it like that's how this MCP server works, or some kind of limited context. And I don't know how the next piece of software you encounter will do it. It might be quite different. It might use the same word that I'm using now to mean something subtly different, which, so I think the bounded context I always thought was going to be an enduring principle. I would have predicted that an AI would need bounded context. I don't think I would have really predicted that an AI would get benefit from ubiquitous language. I think I thought of that as a human thing, a way for us humans to talk to each other and work through problems in this weird way that human brains work that's very language oriented. But now we've invented a thing which we train by feeding it mind-boggling amounts of human-generated language, and then it learns to imitate that. Literally, that's what it learns to do in pre-training. So maybe this isn't as surprising as all that. Oh, now we've invented, and now we call it a language model. And oh, and look, using ubiquitous language helps us to get a more predictable result, to reduce hallucinations and so on.
And it's actually for me as a software engineer, initially this was a bit of irritating. Like when we're building software and using ubiquitous language, kind of meant that the bugs will be easier to catch, or that there will be less bugs because the software maps to the mental model of humans, so it will be easier to explain. But you could never put a concrete number on that. You could never say, "Hey, it saved us 10,000 euros" or something like that. And now you can measure the effectiveness, the power of a single word. Because if you change a word and increases the accuracy, for example, to by 1%, or if it reduces the number of mistakes by 1%, and it translates to 10 hours being saved every month of a person that is usually paid something like 100 euros. So it ultimately, the power of a word get translated to financial figures. And I don't think that we ever had this capability for the to measure value of ubiquitous language or the power of naming things right before.
Yeah, that's interesting. I think what you're saying is there are cases in which you can measure because of course I don't think you can always, for example, when I'm working with a coding agent, uh, I think saying that you were pointing out that there are cases where you can actually measure the impact of refining the language, change this name
Yes.
of something or clarify the way these terms work, and you get a 2% improvement in the accuracy, and that translates into some kind of economic value that you can measure. I think there's still cases where you can't. Like if you're using the coding agent, if I'm using Claude Code and I will be trying to refine ubiquitous language of whatever we're working on. And by we, I mean me and Claude Code. I can't help,
Mhm.
anthropomorphizing it a bit, and that's all right, I think. But anyway, the point is that I'm convinced that the AI coding agents work better. They produce better code and low-level design when the language is very clear, when the, domain language that you're using on that is very, very clear. I can't measure that so precisely the way that in your example. I kind of have to rely on the same kind of assessment that I always have on that. But it does feel that way to me. It's certainly easier to get it to the point where you can say, this piece is working well. But yeah, it is a good point that you make. Um, this whole evaluation and measurement issue, like this is a part of the whole thing that I have more recently been trying to improve my understanding of, get better at. Like most people, the fun part usually for me is to figure out how to make it do something interesting or figure out what that problem is. Like come up with a really interesting problem and find the the key, the linchpin where putting a little bit of AI in will actually make it work. And then figuring out how to make that actually come together. And all that stuff, very fun. And then actually measuring how well it worked. Oh, that sounds tedious. But I think it's really important. And I am actually starting to get more focused on that and get better at that. It's a real learning curve. It's one that I don't think I was ever like during my fairly long software career. We didn't even have unit tests when I was a junior programmer. The the popularity of creating a test suite for your software, that really happened when I was kind of transitioning from junior to senior developer, I guess. And I thought it was a great idea, but I was never one of the ones that uh, was pushing the envelope on that. Uh, I was sort of, I guess, a relatively early adopter, but that was because of the community I was in, and I could see, oh yeah, this is clearly better, but it didn't turn me on. And I had friends who said, crafting the test suite, that's really where it's at. And they would show me things, and I would realize, oh, I see what you mean. And I would follow along. I would realize, oh yeah, you can really refine the ubiquitous language sometimes better from within the test suite because it shifts your perspective to the use of the language to express problem scenarios, to the results, and not the problem itself. And the code is mostly like making the language, but the test suite is using the language. And so I guess what I'm saying is there I wasn't one of the innovators, but I eventually followed the innovators and realized, this is really nice. And now I'm absolutely devoted to that kind of testing. And I wouldn't think of, you know, I don't know, walking the tightrope without a net or just even trying to think through a complex problem completely from the solution side without any. And I think this is like that, except for one additional thing. So it's like that because you have to say, well, what are the characteristics that I'm really wanting this thing to have? So how can I measure them? in a case where we have also random variability thrown in. We have this stochastic aspect to these models. So we don't know the exact answer they're going to give. We have to have ways of assessing accuracy without, well, it depends. Of course, some of them, you say there is one exact correct answer, and that's what we want. And if we get anything else, it's wrong. So, of course, that's where we always start with. I mean, that's the easiest thing to test. But with the example that I was giving of saying what domains are in this code, even that problem is hard to put into a just simply right and wrong solution. You could look at some code and you could say, this is financial software, or you could say this is related to wholesale. Uh, oh, it's invoicing. So is invoicing financial, wholesale? It's both. So I guess ideally I would have labeled it as both. But so for example, I started using instead of just correct, true, false, I had it give me a confidence in each of the ones that it chose. And then I said, I'll look at how confident it is relative to which ones I thought were the right ones. So then it's very much a loss metric that I can add up with a log loss formula similar to the cross entropy loss that we use in training. And that worked. That worked well. Um, I guess I'm getting at that I am getting into this. I think you're further down that path than I am, much further down that path. And leading this whole, I was looking at that suite of evaluations that you've created for the agent challenge. And I think, yeah, it's so interesting to see really like on a topic where I'd have thought, boy, it's going to be awfully hard to create an evaluation suite for a thing like this, where the whole point is that it's an agent doing things and has some freedom in how it might approach the problem. And yet, yes, you can. If you really think deeply about the problem, you can come up with ways to evaluate. And so this is a learning curve that I am trying to climb right now. Uh, yeah.
But this is, I think, is a very amazing and interesting journey. And I know that we can continue talking for a few more hours, and I always love to do that. But just to wrap this up, just one last question. So you're mentioning about multiple different problems from the past, like financial invoicing. We all know about the logistics example from the domain-driven design. Uh, and if you had a smart team, like for example, from this enterprise rep challenge, and there are some really smart people coming from large companies or the smart startups that have been beating already the previous benchmarks, that have been solving that writing agents that solve very complicated problems. For example, in one of the problems, there is a problem of context where the user is saying that he is CEO of the company and he's asked for another identity. And this, although the user is not, this is the user of the CEO, but he's is coming from the public chat. So this information is coming in the context that which the model should detect that it is not actually this somebody who is lying and should solve that. And people have been building agents that detect that problem and fix that. So these are really smart teams. So if you had like 3 months of time, for example, and you had a team of like smartest developers in the Enterprise Rack Challenge, and you had the ability to work on any business or enterprise problem in the world, like which kind of the problems would you be interested in solving, like the Eric Evans?
Well, I mean, I would think about that question before I answered it because an off the top of my head answer would probably not be a very good one, but there are so many, so there are different ways of thinking about it. Like you kind of framed it at first, like if it were in the context of an enterprise or something. And then it very much depends on where you are, right? Like you have to figure out like what are the really important problems to be solved here. There's all kinds of, when you're in a real project or a real organization, this is where the strategic design aspects come in. You say, there's all kinds of things we could do. There are interesting problems we could try to solve, but which ones will really matter? Which ones will, if you could make this a little bit better, the results of the organization would be better in an important way. Um, and if you take it out of that setting, it's hard to evaluate what sort of uh, problem you should even be working on. So when I work on my side projects, I'm driven in part by things that I want. Like I've always thought, I mentioned the email thing that I keep coming back to because there's information in there that I want to be able to do things with, or that I I have these relationships that I neglect, and I don't even know what they are because my mind is just not as good as I wish it were. Keeping track of hundreds of people and remembering that I haven't talked to Joe for years, and I always liked talking to Joe. And this software will say, well, you used to talk to Joe a lot and you don't talk to them anymore. So, I pick things that are important to me. Uh, and but in a general sense, I don't think it's an answerable question, if you see what I mean. But in any specific situation, you have to understand what's important to that organization and where are there complex domain questions that are not readily addressable by old-fashioned software. I have this theory that actually we may pull back a little on the old-fashioned software. Here's a scenario that, so on many projects that I was on involved with in the past, we would come up, there'd be sort of, you could imagine a stream of problems coming into the software that we have to solve. It's usually not that straightforward of a flow, but just imagine that for convenience. And then we would be able to handle, say, 80% of those with a really nice, clear model. Um, but we can't, 80% isn't an acceptable level. So we make the model a little more elaborate, and now we can handle 90%, and that's great, but 90% isn't quite enough. So then we start putting all this special case logic, and the software starts getting quite complex and more brittle, more fragile. And now we get up to 95%, and they say, all right, one thing I started doing more explicitly and early is saying, can we identify those others and then deliberately divert that to some kind of human processing? So, put it into a queue that some person would respond to. Because you can keep going down that path, right? You can say, well, let's try to get it to 92%. Let's get it to 93%. But all the while, your model gets more and more convoluted and less clear about that. The first 80% came with such clarity, and then the 90 was pretty good. So what I'm saying here is, suppose we had another thing, not the full-on send it to a human, but not like I'm going to have to work out every possible uh, logic pathway, which I have to do for conventional software, right? In other words, something like an LLM with, an AI agent. So we say, let's split the stream up. This can be handled with traditional domain modeling and logic. This stream will go to humans, but this one in the middle goes to some kind of AI agent. And having that extra stream at first will people say, the big opportunity is to reduce the number of humans that we have, or reduce the number of cases that have to be looked at by a human. But I think another opportunity that might start to be noticed later is maybe instead of pushing that to the 92%, we should have just gone to the 90% where the design was still pretty nice, where everything was clear and it was easy to maintain. Or even the 80, where everything was just really, that was a simple model that everybody could understand at a glance and it handled 80%. And then things start to get weird once you go above the 80%. I feel like there might be quite a large class of problems like that, where we might pull our conventional software back just a little bit out of those tricky edge cases and say, this kind of software is not for the edge cases. It's for the 80 or 90% that's always sort of the same. And we can process that stuff with total reproducibility and speed and cheapness, and then focus more expensive resources. The next tier is the LLMs. We focus those on the more variability cases, right? The ones that we don't want to model in every aspect. But we focus on what outcomes we want. And finally, of course, a little residual where we use a full-on human, which is still the best model, at least for now.
This for now.
And but anyway, so I guess I'm thinking, do we actually reduce the capability of our conventional software a little, but in the process make it much simpler and more maintainable?
So
There's an op I think about all kinds of stuff all the time. I'm not really good at the what would your favorite thing to do be if you had all these resources and stuff? Yeah, but there was another one that just came out, so I don't have a very good answer to your question.
But ultimately, like as I've been listening to your explanation, so it boils down to a very interesting and unique perspective, is that not using LLMs as a tool to automate processes, but look at the capabilities that are used, for example, by the software and its specter, and to kind of use LLM as a new tool, which has its own limitations and usage, to kind of rebalance the economy of writing the software, of maintaining that. So it's maybe it delivers the same set of features or capabilities, or maybe even less, but at its heart, the complexity is reduced, making it
Yeah.
faster, easier, and maybe even being able to adapt faster because everything is changing like so fast these days.
Right. That's my thought that once we've assimilated this a bit. Now, I mean, if you believe that in the near future we're going to have AGI and all that stuff, then none of this is relevant. So I kind of operate on the assumption that something like what we have now, but of course better, but essentially in character a lot like what we have, will be what we're working with for several years to come. So these are tools that have certain characteristics and they can handle certain kinds of logic very well and other kinds not very well. We'll get very good at knowing, we're recognizing the kind of problem that an LLM would solve well and saying, let's put an LLM on that one. Versus this is one thing we're already pretty good at is recognizing the kind of problem that conventional software is good at. And the thing that we've gotten so good at that we don't even fully realize we're doing it is sort of restructuring that question, saying, I need to frame the problem so that I can say, we will create a piece of software that will do this. And then that will allow us to create a system that includes the software and the people that can handle that class of problems. And so then if you throw this new tool in there, that process will change. We will say, ah, now I recognize this aspect of the problem can be handled by the LLMs. And as I say, at first, the big opportunity there that we'll be thinking about is I can use an LLM instead of humans for that part. But I think as we get good at it, we'll realize that we've we have pushed conventional software into outside of its envelope where it really is the best because it was the only tool we had. We had conventional software and we had humans. And so humans are so expensive that we would push the conventional software and push it into cases that made the code very complex.
And now we have new balance.
Yeah, now we can rebalance. We can say, sure, we still have the humans. They're still expensive. The LLMs are very expensive compared to conventional software, but not compared to humans. Also, of course, when we get good at using LLMs, we'll find that sometimes we don't need a big one. We can, like, my example of classifying domains. Once I zeroed in on saying, let's use NAICS, and so on, I didn't need a big model, so it wasn't really an expensive task after all. Whereas when I was making the thing invent a whole taxonomy, I need the biggest model I could get for that job. So we'll get good at using LLMs. We'll get good at recognizing, reframing problems to divide into these different, categories. Uh, I'm sure there's more than those three, but those three big categories in terms of how you deal with complexity in the domain, right? Do you write conventional software with an elegant domain model? Do you use a human who's very flexible and can be reliable if you give the right incentives, or do you use an LLM? And how do you frame the problem so that LLMs are good at it, so they're somewhat repeatable, and of course, along with it, evaluation, so we know it's working. And I think that's probably what will happen over the next several years. Um, if the people who think that we're going to have a sudden take off with AGI or something, if they're right, then none of this matters. All this conversation is just like for fun. But I kind of don't think that's what's going to happen. But I would argue two things. One, I actually don't think that's what will happen. Maybe, 20 years from now, but that's not what we're concerned with. Uh, but um, if it does happen, there's no point in planning for that scenario. So you may as well focus on the scenarios where your planning actually matters. So that's what I think. We have a wonderful new tool. It can understand natural language. It can do flexible kind of logic on the things it's doing. Um, so we just need to get good at it, really good at it. Like we will look back on this period and say, why, why did we do it that way? It was just so clumsy. And 5 years from now, we look back and say, oh, we were doing such clumsy things. But that's the way it is. Take a look at a late 90s framework for making websites if you want to see clumsy.
Yeah.
Okay.
Yeah,
Yeah.
so things are changing. It feels like we're in a new discovery era. Like when there are so many new opportunities, everybody kind of starts sensing that the economics have changed, that you can do new things, but how to approach new things, how to balance like this classical software, how to balance humans, how to balance LLMs so that they can deliver more value. Uh, Nobody knows exactly, although a lot of companies are already betting a lot of money on that, like the Project Stargate, all the huge data centers,
Oh,
all the
yeah.
investments by the countries and corporations. So this sounds like a very exciting and interesting era. And probably And you were touching on very interesting topics, like on this new balance of the software and AI. So I'm pretty sure that if when we get to record something else, the first question I'm going to ask, it has been already voiced by the audience. So when is Eric going to publish his next book on the economic, tackling the complexity in the heart of the software, where the AI is already a tool on the table? But let's leave it to the next time. Uh,
Yeah, I think that but I can answer it, and that is, I'm not going to write that book. By the time I'm going to dive into this at a time when we don't know the answer. Like right now, I write blog, right? I write a blog because a blog is expected to be in the moment. It's expected to be kind of wrong about some things because we're still figuring it out. By the time we would reach the point where a book could be written about how to do it, there would be, let's say, as good as say to have as much right in it as my book had, then that's still pretty far in the future. So probably not me. Uh,
So now it is not the time for writing a book, but it is the time about which the books will be written about.
yes, yes. We will learn. Now we're doing this stuff to learn to do that. And this is the most exciting time. This
Yes,
is,
yeah.
I feel fresh again. I've been feeling quite stale in the last decade or so. Like, it's not that I didn't have interesting work to do and interesting problems, but they were very similar in nature to the problems that I had worked on for a long time. And I thought, well, maybe I should just do something else or retire or something. And then along came this, and I don't want to retire. I don't want to do something else. This is the most interesting thing in software of my whole career. And yeah, I'm having a great time. And if this feeling that we don't know the right answer, that like we're going to try things and they'll sort of work and they sort of won't work. And that means that we have a lot more to learn and a lot more to try. That's why it's exciting. When you get to the point where you know the right answer and you do it and it works, yeah, I mean, that's good, but that's not going to keep you interested very long. So, enjoy this next decade. This is the golden decade when we're going to get to be, as you say, the people that they talk about in the books about how to do it right. They'll say, don't do it the way Eric Evans did it. It might have made some kind of sense at the time. I don't know what people in the mid 2020s were thinking about it. Just don't do that.
But thanks to the work that they've done, thanks to the exploration, now now we have ability and time to settle down and write a book.
Yeah,
Yes.
and so we're in the fun time. And things like learning how to measure, whether we're even doing it right or not, like, things like that are important too. Um, I think it is, by the way, it's funny detail, but you call it the RAG challenge agents, this one. And so we had this lengthy conversation about how good it is to have names, good names. And yeah, so the RAG challenge is the name of the thing now, but your new challenge is not actually a RAG challenge. So I think that's very funny.
Actually, it was there was additional twist because in this part of the benchmark there is also a wiki because each company has a backstory, and some people were complaining that because there are subtle differences, for example, between the wiki and the APIs, and the model has to reconcile that. The Wikipedia, for example, says that there is a system, but their system doesn't exist in the API, and the agent has to decide what to do. And they were saying like, hey, so after all, this is also a RAG challenge because ultimately it is about dealing with information, figuring out the right answers, finding the information, even if though some of the RAG is in text and some of the RAG is in the descriptions of APIs, some of the RAG it's inside the APIs as a data. But it's just this is just all are implementation details. Ultimately, all these details, they can be expressed as a language, and we're using tools like large language models, which are good at language, and also using our understanding about the context for context engineering and language precision, all which we've taken from the DDD to try to solve these problems and kind of push state of the art a little bit further and have some fun.
Yeah. I mean, RAG is going to be a part of any non-trivial project because you have to look stuff up. And when
Yep.
you say, I mean, anything that's not just dead simple is going to have some looking up information. Unless we end up, like fine-tuning that knowledge into some specialty model, maybe that'll be a thing again. I always thought that would be really fun. Right now, that's not the trend, but yeah, I do think, another thing to keep in mind is not quite as in our face as some of the others, but bounded context, I just say, I think that's an important one. I think that distinguishing between, between the model itself and the problem space that the model is working on, the context that the data came from, if it's RAG, is coming from some other thing altogether, to really be aware of the bounded context. And the fact that we call the context window of an LLM a context window, I don't think that's not a coincidence. It's just using the word context for what it means. And same, bounded context is using the context word for what it means. So there's a lot of old stuff that we can still use, and then some things we'll probably end up just not needing.
We'll see how it goes. And then we'll see how it goes. We'll see which part of that is correct, which is not incorrect. And then they'll write a book about that.
Yeah.
Okay. Thank you very much for your perspective. And it was an honor to have you on this presentation for the Enterprise Rack Challenge. And we'll share this also on the YouTube with the links. And if there are any upcoming blog posts from you, we'll just also share that. And next step is to see what the amazing teams and the amazing community of LM Under the Hood has coded to solve these challenges and
Yeah.
learn from their discoveries.
Very interesting stuff. Thank you very much for inviting me.
Thank you. It has been an honor.